Good morning, 8th grade. We're going to continue on with our beta decay. I'm in a new location, and so I don't have my whiteboard, so we're going to write on paper. Also, some of you noticed my pictures. I don't have the pictures anymore, but we're going to do the best we can to try to make this as exciting a class as possible. So let's move on. So the last time we were talking about beta electron, I think some of you may have been a little bit confused because when we spoke on the Zoom meeting, some of you mentioned that you didn't exactly understand what a beta particle is. So there are actually two kinds of beta particles. The one that we discussed in detail is the electron beta particle, and basically would be a beta sign, which is that B with a little stem on it. It has a -1, which is the charge because it's an electron, and then it has a 0 weight. Okay, so anytime we were to write an element, right, we always put the amount of protons on the bottom, and then we put the atomic mass on the top. So here, when we're writing our beta particle, when the one that we're talking about, the electron, would have that -1, kind of representing the atomic number, but you know, it's not the atomic number because it's not protons, but it's representing the electrons, which has a negative charge, and then your atomic mass would be on top, and the mass is 0 for an electron. Well, when we talk about a positron, which is the opposite of an electron, it would be the same. It would be a similar symbol, not the same. It would be the same B with that stem, but it would be a +1, and again, it would have a 0 mass. So this is how I would write a beta electron, and this is how I would write a beta positron. Okay. Now, the beta decay would happen if the nucleus were unstable due to having too many neutrons or due to having too many protons, okay? And so in the case of having too many neutrons, it's going to undergo electron beta decay. And if you think about it, if we had a neutron, right? A neutron is a combination of both a proton and an electron together. So because a neutron is a combination of both the proton and the electron, what would happen is we have too many neutrons. We're going to get rid of the neutrons and break them apart. Well, when the atom breaks those neutrons apart, what we end up with is a proton and an electron. The electrons are not going to stay in the nucleus because electrons don't stay in the nucleus. They're in the outer shells, and so they're going to be sent out. And the proton is going to stay in the nucleus, and that's why that element is going to go through transmutation. It's going to end up with as an element with one more electron than the previous element. One more proton than the previous element, okay? Now, that means that the opposite is true for a positron, right? Why would a positron form? A positron forms when in a situation when the atom has too many protons. So in the electron, the beta electron, the atom had too many neutrons. In the beta positron, the atom has too many protons. And again, the reason why it's going to go through this decay is because either the ratio is not a good ratio, right? We talked about why an atom would be unstable, right? It would be either the ratio between the protons and the neutrons, or because the atom is getting too big and the strong force is weakening, right? So those are those two reasons. If you're unsure about what those reasons are, go back to the other videos and take a look and see what why that would occur, okay? So in this case, we have too many protons, okay? That atom has too many protons. And what it's going to do is that it's going to take a proton and it's going to form a neutron. Well, in order for that proton to turn into a neutron, what does it need? It needs an electron, right? Because a neutron is a combination between a proton and an electron. So a proton plus an electron is going to form this neutron. And that's the goal. That's what it wants to do. But when this fusion happens, when the proton and electron come fusing together, something else is created in that process. And what is created in that process is called a positron. So this fusion, okay, so this will fusion, I think it's Fusion, I think, whatever, either way, SS or ION, whatever. You look it up and tell me if it's spelled right. So protons and electrons will create this neutron, and when that happens, a positron will form as well. So this results in the creation of a positron. And we've never talked about positrons before because they actually don't exist within the nucleus or the atom at all, right? In the nucleus or the electron shells at all, whereas electrons, we know, reside in the electron shells, but these positrons we never talked about before. And they only form in this fusion of a proton and electron turning into a neutron, okay? So this is a completely new subatomic particle that we've never discussed before. And again, we talked about how it's going to have this symbol, right? The +1 representing its charge and the 0 mass representing that it really has no mass at all. Okay, so now once this positron forms, it doesn't want to stay in the nucleus. It's not going to stay in the nucleus. And so the atom is going to emit this positron outside of the nucleus, okay? This is called a beta particle, right? Either this over here, this electron is called a beta particle when it undergoes decay, and this positron is considered a beta particle when it undergoes decay. Similarly to what we talked about previously when it comes to alpha particles, right? When alpha particles are emitted from the nucleus. And if you're not sure what an alpha particle is, go back to the other videos and take a look and see what that alpha particle is as far as its weight, as far as its atomic mass. Atomic mass and atomic number. Okay, so this positron is going to be sent out and a neutron is going to form. But this element is going to undergo transmutation. And the reason, and you're thinking, oh, but it's just a neutron that's formed. It's not a proton that's formed. So why would it undergo transmutation? You could understand why that would happen in this case, right? Where a neutron is going to send in an extra proton. Well, hopefully you guys understand why that would happen in this case as well. Because we used to have more protons and now we have less protons, right? So anytime you change the number of protons, whether it's adding or subtracting, it doesn't matter, right? Anytime there's a change in the number of protons, it's going to result in transmutation, right? The element is going to change. Okay, so let's now go through an example of a beta decay where a positron is produced, okay? And so let's take the example of oxygen. So we have oxygen. Oxygen has 8 protons, so we'll put the number 8 over here. And we'll say the atomic weight is 15. By the way, when we're talking about the atomic weight, we're not just going to look at the periodic table. I would have to give you that information because it could be various different isotopes, okay? And so what's going to happen is if it undergoes beta decay, right, producing a positron, what are we going to end up having? We're going to end up producing a neutron, right? Which means that we're going to lose a proton, right? We're not gaining a proton, we are losing a proton. That's why the positron will form. And so when this undergoes beta, positron decay, so we're going to have an arrow indicating what is going to be the resulting products. And there's going to be 2 resulting products. One is going to be the actual positron that's formed, and the second thing is going to be the new element that is formed. So first let's write down this positron. So we have the B with a +1, and it has a atomic mass of 0, plus what the new element is. So if I take oxygen, which is 8, and I take away a proton, I'm going to end up with an element that has 7 protons instead of 8, and that element, if you look at your periodic table, is nitrogen. So I have nitrogen over here, and then my atomic mass is going to be the same as the atomic mass of the original element of oxygen. And the reason for that is because if a proton and a neutron weigh the same, well, if I'm losing a proton and I'm gaining a neutron, it doesn't matter, right? Nothing was gained or lost. It's the same mass, okay? So this nitrogen is going to end up with an atomic mass of 15, right? But it's going to have the atomic number of 7. So oxygen underwent transmutation, turned into nitrogen. It's going to produce this positron, which is going to just be sent out of the nucleus. And this is what's going to be your resulting equation, okay? And if we want to take a look and see if it ends up actually balancing out on both sides, right? We have 8 over here as far as the amount of protons, right? As far as our charge, we have number 8. Oh, this is also green. We have the number 8 as far as our charge over here. And if you looked on this side of the equation, we have a positive 1 plus 7. Positive 1 plus 7 is 8. And if you look at our atomic mass, we have a 15. If you look at the atomic mass on this side, we have 0 plus 15 is 15. So the equation balances out. Okay, so that is the basically the end of beta positron decay and beta electron decay. So we did alpha decay and we did beta decay. The last type of decay is called gamma. Gamma decay. And I think what I'm going to do, even though it is a little bit early, normally I go 15 minutes for a video, but because this is going to be a completely new part of this topic and it's going to something completely new, and I'm probably not going to be able to finish it in 5 minutes, I'm going to save that for tomorrow. So today you only get a 10-minute video, but you still have a bunch of questions. I'll probably give you about 4 questions on your assignment for today. And that will be it. So have a great day, and I will see you later at our Zoom meeting.